According to the title, the planet Hell on Earth is made of 30% pure diamond. Astronomers and scientists are only beginning to delve into the huge secrets of our galaxy in the current era of space exploration. They have opened up a new exploration area with the recent finding of the planet 55 Cancri. Scientists were initially unsure whether the planet was rocky or simply a huge ball of gas, as is the case with many planets discovered outside of our solar system. Have you ever heard of planets made entirely of a diamond? 55 Cancri E is one of them, but not the only one. It is the richest by mass and has a surface of 30% pure diamond. Ever wondered how this planet came to be? Watch this video to learn more. In 2004, astronomers found a planet revolving around the Sun like star 55 Cancri. A binary star system with 55 Cancri, also called Rho Cancri or Hell on Earth, is located about 40 light-years away, in the Y form of Cancer. One orbit of the star 55 Cancri E takes place every 18 hours, has a surface temperature of more than 2200 degrees C, and a mass around 6 times that of the Earth. As one of the galaxy's densest planets, 55 Cancri E is extremely precious since it contains 30% pure diamond. We will discuss the physical description of this planet, its history of discovery, and how it was formed in this video. To find out more about the priceless planet, watch this video. Please give this video a thumbs up and subscribe to this channel for more. Just like before we continue. Click the bell icon to receive notifications of new videos. Did you do that already? Let's get going. The discovery of a supposedly diamond-rich planet orbiting a nearby star has added a little bit of wealth to the universe. According to a new study, the rocky planet 55 Cancri E is only twice as big as Earth but has 8 times as much mass, making it a super-Earth. The close-in planet's passage in front of its parent star was first observed in 2011. It cycles its star in about 18 hours. As a result, the surface reaches an unlivable 3,900 degrees Fahrenheit, 2,150 degrees Celsius, which when combined with carbon, creates the ideal environment for the formation of diamonds. NASA's Spitzer Space Telescope measured the orbital distance and mass of the planet, and the ensuing computer models allowed scientists to reconstruct the composition of 55 Cancri. According to study leader Nico Madhusudan, a postdoctoral researcher at Yale University, science fiction has dreamed of diamond planets for many years, so it's remarkable that we finally have evidence of its existence in the real universe. This is a profound paradigm shift in our knowledge of what is conceivable in planetary chemistry, because it's the first time we are aware of such an exotic planet that we believe was born largely of carbon. The gem-like planet is located in the northern Cancer constellation, only 40 light-years from Earth. The host star of 55 Cancri E can be seen with the unaided eye under clear conditions. Strange chemistry on Diamond Planet. The new theories agree with earlier research that the progenitor star of 55 Cancri E contained much more carbon than our Sun. The entire planetary system should be carbon-rich according to Madhusudan, whose research will be published in a future issue of the Astrophysical Journal Letters. If we assume that the star and its surrounding planets are all born from the same primordial disk of material, then it makes sense that the entire planetary system would be carbon-rich, he added. About 55 Cancri E. Super-Earth exoplanet 55 Cancri E revolves around a G-type star that resembles the Sun. It has an 8.08 Earth mass, completes one orbit around its star in 0.7 days, and is 0.01544 AU away. In 2004, news of its finding was released. Its surface is around 4,900 degrees Fahrenheit hot, 2,700 degrees Celsius. It was given the nickname Diamond Planet for a period because researchers hypothesized that it was made of diamonds and graphite. Even though that idea is less widely accepted now, the planet's high density and proximity to its parent star make it an intriguing object for research. Its extremely heated surface and atmosphere have been the subject of several follow-up studies that have provided more information. 55 Cancri E, commonly known as Janssen, revolves around the star Copernicus, which is only 41 light-years away. Although the molten surface is entirely uninhabitable, Jansen's sister planet, Galileo, hovers in the night sky above the burning horizon. On the dark side of the tidally locked planet, silicates in the atmosphere would condense as clouds, reflecting the lava below. Thus, the sky would be sparkling. Early research and observations. After studying the spectrum of its parent star 55 Cancri A, one of two stars in a binary system around 40 light-years from Earth in the constellation Cancer, astronomers identified the planet in 2004. At least 4 other planets exist in the same system, most of which were found before 55 Cancri E. The team, led by Barbara MacArthur of the University of Texas at Austin, found tiny tugs on the parent star that the presence of yet another planet might cause. While a second study team questioned the planet's existence in 2005, a different team later confirmed it in 2006. When measurements were made in 2011, it became clear that the planet 55 Cancri E, also known as 55 Cancri, is far closer to its parent than previously assumed. An orbital period of under 18 hours was revealed by observations made with Canada's most microvariability oscillations of stars satellite observatory. According to researchers, the surface temperature of 55 Cancri E might reach 4,892 Fahrenheit, 2,700 Celsius. The Spitzer Space Telescope's follow-up studies in 2012 revealed that 55 Cancri E is much weirder than expected. Spitzer hypothesized that the planet contains a healthy amount of light elements and compounds despite initial estimations that it is thick and rocky such as water. However, the researchers asserted that the planet's high surface temperatures contribute to a supercritical fluid state in which the gases resemble liquid. Additional NASA discoveries. It was revealed in February 2016 that NASA's Hubble Space Telescope had discovered hydrogen cyanide but not water vapor in the atmosphere of 55 Cancri E, which is only possible if the atmosphere is primarily composed of hydrogen or helium. This is the first successful analysis of the atmosphere of a super-Earth exoplanet. It was revealed in November 2017 that Spitzer Space Telescope infrared measurements revealed the existence of a worldwide lava ocean that was hidden by an atmosphere with a pressure of roughly 1.4 bar, somewhat thicker than that of Earth. Similar compounds like those found in Earth's atmosphere, such as nitrogen and perhaps oxygen, may be present in space, contributing to the Spitzer infrared data. In contrast to the February 2016 findings, a spectroscopic investigation in 2012 and a spectroscopic examination 2020 failed to identify escaping hydrogen and helium, suggesting that the planet likely lacks a primordial atmosphere. These statistics do not rule out the possibility of heavier molecular atmospheres, such as those composed of oxygen and nitrogen. Diamond Planet and its waning luster. In 2012, a model of the planet's interior revealed that 55 Cancri E's composition included carbon, mostly in the form of diamonds and graphite, iron, silicon carbide, and maybe silicates. According to lead researcher Niku Madhusudan of Yale University, their model differs from earlier ones because they did not base their assumptions on Earth's chemical composition. Joanna Teskey, a PhD student in astronomy at the University of Arizona, refuted this notion in 2013. She claimed, in a statement made at the time, that the parent star 55 Cancri E is both colder and richer in metals than the Sun. Additionally, she said that the 2012 study made potential mistakes by improperly analyzing the star's sole oxygen line in the spectrum. Instead, she discovered that the host star 55 Cancri E had a 25% oxygen to carbon ratio. Teskey noted in the statement that although the host star does not have a very high carbon to oxygen ratio, 55 Cancri E may nevertheless theoretically have a high carbon to oxygen ratio and be a diamond planet. Therefore, the measurements of the star no longer verify the two fundamental pieces of knowledge that made up the initial diamond planet hypothesis: the exoplanet and the star measurements. Why the extreme temperature? However, ongoing research into the planet aims to understand its peculiar characteristics better. Between 2013 and 2016, researchers used the Hubble and Spitzer space telescopes to monitor the planet. Their findings were then published. Volcanoes, or runny lava, are two theories put forth concerning its surface that could assist explain why there are such large temperature differences between day and night. The planet's envelope is thought to be primarily composed of hydrogen and helium, more like that of a gas giant than an Earth-type planet, according to studies of its atmosphere. By 2022, the observation had revealed significant variability in the planetary transit depths, which can be attributed to large-scale volcanism or the presence of the variable gas Taurus co-orbital with the planet. Large surface temperature variations on 55 Cancri E have been attributed to possible volcanic activity releasing large clouds of dust that blanket the planet and block thermal emissions. According to Princeton astronomer David Spergel, the Diamond Planet is likely the first of a brand new type of planet whose chemistry has never been observed. According to Spergel, who is not involved in the new study, this planetary system is packed with carbon, unlike our solar system, which is dominated by oxygen and silicates. There's no doubt that this is an essential step towards understanding the whole diversity of planets, he added. But it's still unclear exactly what implications this will have on our knowledge of the evolution of planetary systems. We've concluded today's video. Don't forget to subscribe to the channel and give this video a thumbs up if you enjoyed it. Remember to click the bell icon to get alerts when new videos are posted. Bye for now. See you in the future video.